lesson 37. We'll talk about complex numbers. They're imaginary. We'll talk about complex plane. It's very nice. You can graph them. It's good because problem we had before was that we wound up with answer, which was, we would have a quadratic and we will come up with answer. Well, let's see. Let's have a look at this. Remember, you would have answer that had negative underneath your square root, and you would say this is not real. You are crazy. You can't. This is not a thing. Why are you trying to trick me all the time? And so now you can say, oh, I see your tricks. I fix you. Okay. I don't know why we are doing this, Eureka, but we will. There we go. X is equal to 1. That was so hard. Oh, my brain is broken. This one is x is equal to negative 1, right? And then we are getting to the point eventually where we wind up with the square root, right? We get plus or minus 1 for this one. But, something very freaky happens right here. I feel like I sound like Count Dracula. And then we say, okay, we take square root of both sides, and it is plus or minus the square root of negative 1, and you put this into your calculator, and your calculator tells you, you shut up. No, it tells you that there is an error, right? This is a non-real quantity. And that is true. There is no such thing as a negative square root, okay? But we are going to take care of it, okay? So, we will do so. Alright, so I'm going to write down a bunch of extra stuff. You have some space in your module. I'm going to put it in there. Okay. So you have this space in module, and you're going to write this, okay? It turns out that what this is, so a mathematician said, we have too many problems that the solution is not a real solution. But I need to be able to do something with this not a real solution, because I'm trying to build a building or something. I'm trying to model some particle motion or something very complicated. And so they said, I cannot just stop. I need to actually get project done. So we have to do something about square root of negative numbers. And he said, I don't think that I is taken in the alphabet for something special in math. So let's go ahead and call it I. So it turns out that every single time, square root of negative 1 is I. Right? And what that means is that I could say that I could do this. So now, if I had something like square root of negative 36, now I don't have to say it's not real. I can split this up, right? This is the same thing as square root of negative. You know what? If this was right, that is times negative 1, right? Same thing. Okay. So then this is then square root of 36 times square root of negative 1. But we have said that square root of negative 1 is I. So I'll come back over here, my typewriter, okay? And square root of 36 is 6, and square root of negative 1 is I. So now I have a good answer. I use letter instead, and everything is okay. So this is how we use I. There are some things that we need to know about I, and that is that it always follows patterns. Okay? So we have patterns. Square root of negative 1 is I. What is then I squared? Square root of negative 1 times square root of negative 1. This is I squared, right? If I is square root of negative 1, right? then I times I is square root negative 1 times square root negative 1. What happens when I multiply square root times square root? Square roots go away. I simply can't help but roll my R's. Okay, so then if this is true, then what is I cube? Well, we have run out of space, but it's okay. Square root negative 1 times square root negative 1 times square root negative 1, right? Which is same thing as negative 1 times I. So like this, alright? Because this one, the square root negative 1 times square root negative 1 is this. And then this right here is I. So we have negative 1 times I. And then this pattern will continue and repeat at some point. We'll find the point where it will repeat, right? No. Okay. So then what is I to fourth power? I to fourth power is square root negative I times square root negative I times square root negative I times square root negative I. So these two, this is negative 1, right? And these two is also negative 1. No? Right? Because this is right, I times negative. So this one is this right here. And this right here, the same thing. So I have negative 1 times negative 1 out of 1 is I to fourth power. It's quite new and different. But so it's riding on a carousel in the rain, but we do it. You never ride carousel in the rain? It's fun. It's a rush. It's much more fun than playing with nails. And I'm not talking about the ones who drive in the boat. Okay, so what is I to fifth power then? Is square root I times square root negative 1 times square root negative 1. I run out of room. I've been ransacked. I go this way. Square root negative 1, square root negative 1, square root negative 1. So what is this? Eventually we'll come back to I. I've never played with human nails, so I want to play with the nails of animals. I have no Toys R Us, okay? I have no Toys R Us. I do what I can. Rocks are old, boring, they're not fun. So what is this? We've determined that this is negative 1. This, we have determined, is also negative 1. And this is I. So where are we now? Back to I. Yes.
Like, negative 1 plus what?
Yes. Huh?
Like, on the ice cube, you have like negative I cube, and that's 3 of them.
Alright, so this one times this one is negative 1, right? And that is I. So negative 1 times I is going to give you the negative I. Oh. Hey, pattern has repeated every 4 times. You will repeat. So on the 5th one goes back to I. So if that is true, then what is I to 10,000? So think about it, okay? I to 10. So 6 is going to go, so we have our I. So 6th powder will be I squared. 7th powder will be same as this one. 8th powder will be same as this one. 9th powder will be same as this one. So where will we be in pattern? Negative 1. You can also, let me show you something very nice and special. If you have your graphing utility or calculator nearby to you, in Russia we are not giving toys, we are giving graphing utilities. That's why we are so much better than America. America is inferior. So it's possible for me to calculate these things. I can say to my calculator, I have I button, which has not been copyrighted by Apple yet. So I can say I to 10 is negative 1. I was right. I was right. It's new thing, but it's beautiful. It's nice. It fits pattern. I love patterns. It's good. It reminds me of a quilt. I try to relate to something that you American love. You love quilts. I know it. In jet airplanes. Okay. This is what I see on the moon. Okay, so look at this. We have done it. Alright, so let's go ahead and do some addition. Now that we know what I is and how to use it, we'll go ahead and perform some operations with I. So we must add these things together. And it's quite simple. We'll treat I in the same way as we would treat any sort of a regular variable, right? If we have 2 of them, we add 1, we have 3 of them. Same type. Okay, so let's go ahead and add. I'm just going to go ahead and add my my like terms. So parentheses are unnecessary, right? When like some unnecessary things. So because they're unnecessary, I will just take them out. It's okay. It doesn't change problem at all. Okay. Now I will combine my terms. These two are the same. So I get 10 plus and 4i minus 20i. I'll treat it just as if I had an extra, right? So this will be actually negative. I don't know why I put plus sign there because I am becoming irrelevant. Here we go. So it's negative 16i. Okay. So it turns out that we can graph these things in complex planes. this is not complex plane because I have y and x, right? So what we do for a complex plane is we make this I, and this becomes a real. So this is our complex axis, right here, and this is our real number axis. So how do we graph this? We go to let's put 2. These are going to be units of 2, and also units of 2 here. So we're space. So I go to 1, 2, 3, 4, 5, 6, 7. Whoops, I'm going by 2s. So 2, 4, 6, 8, 10. And then I will go down. 2, 4, 6, 8. Essentially, I will go 8 down. 1, 2, 3, 4. And there it is. This is how I plot this point. So this point is 10 minus 16. And that is how we graph. Fantastic. So this is how we graph imaginary numbers.
So what's the answer?
This is the answer to this, and here is a graphic representation.
Do you ever find my I or that I?
What do you mean?
I don't know, like there's still I in here. So you never like solve for I?
No, you'll just leave it. I mean, technically that is 16 times the square root of -1, right? But we'll just leave it at that. We'll continue doing some operations with these, so I'll make one. Okay, and we'll also be graphing them as we go. So let's go ahead and subtract.
Money.
Over everything or just in general? Okay, over everything or in general? What are you for or against? Oh. So I'm going to go ahead and so I distributed my minus sign, and now I'll combine my terms. So this becomes -4 plus 24i. I know that you're waiting for this to get harder, but it's. Oh yeah, so when I distributed that, it became positive. No, but thanks for keeping me on my toes. I like it. All right, so let's go ahead and graph this. Remember, this is our complex, and this is our real number. Okay. So we go -4 on our. Why I can keep picking these large numbers. It's going to be actually off of it. So let's go ahead and go by. Let's go ahead and change this to 4s. We'll go by 4s instead. So we'll go -4 in my real. So right there, right? And then we'll go. And it turns out these are actually vectors. So we'll get into that later. And then we will go, actually we'll never get into that, so sorry. They're actually vectors, but we won't talk about vectors. So, and positive 24 on my imaginary axis, so we'll go, that'll be 12. Or no, since we're going 4, that'll be 8. 1, or 6. 1, 2, 3, 4, 5. So this is where the point is. So that's the point. -4, 24i. We're going to give you a really super fun, easy project to increase your game right before Thanksgiving. And it's going to be involve plotting points on the complex plane. Okay? Yeah. trying to look it up. What is that guy's name who was just talking with the Russian accent? What's his name? He was a professor, wasn't he?
I don't think anyone's gonna remember that, so just say what you want.
Nobody remembers his name?
You didn't say it. You said the name. I remember it.
I didn't say it, he said it.
Oh, yeah, sorry. He said it.
Alright, let's go ahead and multiply. This is where it gets a little better. So I'm going to have to distribute this. Yeah, so 1 times 1 is going to be 1. And then 1 times negative 2i will be negative 2i. And then 2i times 1 will be 2i as well. And then I have this where I have a negative times a negative, it's going to be a negative. And then I times I, well 2 times 2 is 4, and then I times I is I squared. Yeah, everything is special with this one. It's almost as if it's color coordinated too, so that's nice. So 2i minus 2i is 0. And then I'm going to go ahead and write this for this I squared times the 4. It's going to be, isn't this same thing as negative 1 times square root negative 1, like negative square root 1?
Can't do it.
Right? I squared is negative square root of 1 times negative square root of 1, right? What is negative square root of 1 times negative square root of 1? So close. Right? It's negative 1, right? Because remember, like the same reason, right? We had square root of x times square root of x is just x, right? Same reason. So then this actually becomes 1 plus 4, which is equal to 5. Okay, well, we can actually still plot that on our complex point. It's just only going to have a real representation, right? Yes.
So you have 2 negative 1. Once you convert them, it would become, once you turn them regular numbers, it would go from negative 1. No way. Where's the negative 1 come?
Okay, check it out. You know how the square root of x times the square root of x is x? Well, the square root of negative 1 times the square root of negative 1 is negative 1. Yeah? Cool?
Yeah.
No, it's good. It's a good question. It's a great question. All right. Yeah, it's fantastic. Okay, hey, oh my goodness. Let's verify that these two things are solutions to x squared plus 2x plus 5. Now let's get down to the nitty-gritty, as they would say. You're having an existential crisis. Yes. You asked me what was happening. That's just my guess. You're not sure where you fit into this whole thing. Your identity and your idea of being is somewhat conflicted. Yeah. Here we go. Let's go ahead and solve this. So hey, when I look at this thing right here, right, I say to myself, hey, self, is this thing factorable? Are there 2 numbers that multiply to 5 and add to 2?
Yes. No. You say add 1 and add 2.
Multiply to 5 and add to 2.
It'd be like 3. No.
Because the only factors of 5 are 1 and 5, and you can't ever combine those to get 2. So, not factorable. What do we do when we have a quadratic equation that's not factorable? we definitely, every single time, use the quadratic formula. I'm so proud of you, and at the same time, I'm not even disappointed. All right, so we have A equals 1, B equals 2, and C equals 5. We're going to plug those bad boys in there. So, negative B plus or minus the square root of B squared minus 4 times A times C. There it is. All divided by 2 times A. Boom. Let's rock this thing out like it ain't no thing. That should be plus or minus. I think I said it and didn't write it. So this right here is going to be 4 minus 20 over 2. I'll go ahead and put this up over yonder. So we get that x is going to be equal to negative 2 plus or minus the square root of negative 16 all over 2. Still got quite a bit of simplification that we can do, don't we? I'm going to split these bad boys up like they're dating Kylie Jenner. Sorry, no. That's negative 2 over 2. Plus or minus. Sorry, I'm bitter for typing. Just showing you the in-between steps there. All right, that negative 1, I'm going to go back up here, right? So negative 2 over 2 is negative 1. Square root of 16 is 4. Square root of negative 1 is I. We just have one more step to go, right? This is negative 1 plus or minus 2i. Is that true? Absolutely. We have just verified that those two are solutions. Not too bad, right? Just taking some stuff that you already know and throwing a little twist. All right, excellent. So that is done. There's your assignment. Thanks, you guys. Goodbye, friends.
My boy.